Well, hello and welcome, and I'm going to take up another problem of JEE, which was conducted today, in fact. And so the problem says like let n denote the set of all positive integers. Consider the set A containing the first five natural numbers, and the set B containing the first seven natural numbers. And let S be the set of all functions from A to B such that f of 2 is not 2 and f of 4 is not 4. And then they say that T is the set of all f belonging to S such that there exists a function g from B to n such that g of f of x is 2 to the power x for all x belonging to A. Then the number of elements in T is. First of all, the language can seem very confusing, but as always, always ask yourself that uh, why f can't be any function in which f of 2 is not 2 and f of 4 is not 4. And then you'll suddenly realize that something is wrong. Why? So, for example, have a look at this. So, f of 2 can't be f of 2 and f of 3, they can't be simultaneously 2 or they can't be simultaneously 4 or 5 or whatever. Why? Because say that f of 2 is also 4 and f of 3 is also 4, then g of f of 2 is in fact 2 to the 2, and g of f of 3 is in fact 2 to the 3. And since f of 2 and f of 3 are 4, so this will give you a contradiction that g of 4 and g of 4 is 2 square and g of 4 is 2 cube. So that can't be true, which essentially tells you that f is 1, 1. And that's all that is required. So come to think about it, why that's 1, 1. Since g of f of x is 1, 1, 2 to the power x is 1, 1, therefore f must be 1, 1. Right, so you just want to find all the functions f for which g of f of x is 2 to the power x and f is 1, 1. And that's plain and simple. So you want to find the total number of functions f from A to B, which are 1, 1, and for which f of 2 is not 2 and f of 4 is not 4. So I'm just going to use a bit of principle of inclusion exclusion. So total number of 1, 1 functions from set A to set B, since there are 7 elements in B and 5 in A, are 7p5 minus. I'm going to subtract those cases in which f of 2 is 2 and f of 4 is 4. In other words, 2 and 4 are fixed points, as we call it. So say that if 2 is mapped with 2, then the problem is that, and we're still making 1, 1 function, so 6 things and 4 distinct mappings. That's what we have to do. And then since using principle of inclusion exclusion, we must add back those cases in which 2 is mapped with 2 and 4 is mapped with 4, which would mean that there are 5 elements there and 3 here. So we have 5p3. And that gives you a total of 1860. And that's it. So this was a nice combinatorics problem. By the way, if you're interested in learning rational root theorem, which I used in the previous problem, you should buy my book, The Olympiad Companion by Narosa Publication. So let me write it down, The Olympiad Companion by Narosa Publication. You can read the rational root theorem in that book.